Hey everybody, it's Bruce and the dog on the floor, and today we're going to be talking about Elixir's Nx. And in particular, we're going to talk about tensors. This is the data structure that's used to be able to represent multi-dimensional data. It's going to be a great episode, so let's get going. Before we get going too far, I'd like to talk a little bit about the lay of the land. So you can see that there's an umbrella project that's Elixir Nx, and that includes 3 sub-projects. So there's Nx, Xla, and TorchX. So TorchX is a backend for Nx. Remember that Nx is a kind of a wrapper around some other services and other languages that allow us to do machine learning through tensors and things like that, which is multi-dimensional arrays. And Xla is the client for Google's XLA, which is Google's kind of machine learning and numerical analysis platform. And so what's going to happen is we're going to spend a lot of time in Nx, but if you need backends that are based on TorchX and Xla, those are going to be available to you. And you'll see as we go on through the different videos in the series that sometimes we'll drop into one of those backends or another to kind of allow us to hook in those various capabilities of those individual platforms. But today we're going to be spending some time in Nx. So let's go ahead and drill down here and see what's happening. So this is Elixir's Nx, and this is the mascot. That's a numbat. And you can see that there's a couple of capabilities that are laid out here, right? And so one of them is typed multidimensional tensors. And so when you're dealing with numeric computing, this has really traditionally been a place that's been close to Elixir because the individual implementation is a little bit, well, it's not ideal for this type of computing. But with the introduction of some specific backends, which allow us to implement wrappers around technology that's already there for example, Xla or PyTorch, we can actually put thin wrappers around those systems and wrap those with tensors. That's multidimensional data that accesses individual types. And you can see that there is a grouping here of unsigned integers of 8, 16, 32, and 64 sizes, and signed integers of 8, 16, 32, and 64 sizes, floats of size 32 or 64, or Google's brain floats, and these are BF16s, right? So we can create tensors that are of these individual types, and they will allow us, we'll essentially use a kind of an Elixir wrapper or a NIF around those things to access those individual pieces. And that's not all. There's actually some compiler technology, some just-in-time compilation that's going to allow us to do this efficiently and to kind of work interactively in an environment called a notebook. So we're gonna spend some time doing that, and we're gonna rely on the kind of the wrapping and compiler technologies that allow us to have a pretty convenient developer experience. And we'll rely on the backends, that's the Xla and the TorchX backends, to provide an efficient implementation that's not available to Elixir. So that's pretty great, right? And then there's also the capability of doing named tensors. And remember, a tensor, it's just multi-dimensional data. So if you've missed the idea of having a 2 or 3-dimensional array in other languages, then you have access to them in Elixir's Nx. And then there's also this tool called automatic differentiation. And this is actually a tool that's pretty powerful and important in the world of machine learning. What this allows us to do is to compute the gradient. And then with the gradient, we can rapidly find the least loss of a particular kind of function. And doing so, we're going to be able to solve systems of equations quite efficiently. And that's going to enable the whole machine learning stack. And so then we talked about the idea of tensor backends. And this is where we have the APIs and the compiler support that we talked about. And even processing CPUs that are based on the whole idea, they're optimized for the whole concept of machine learning. Now, as you can imagine, we're not going to have all of Elixir available to us when we exercise these wrappers, but we will have some convenient functions called numerical definitions that we define with def-in that allow us to plug into one individual function and to kind of write our custom tensor-aware features that allow us to do numerical computation. And there's some of its convenience and some of it is actually necessary pieces to actually allow us to access our tensors in a way that performs well and is super convenient, which is going to be necessary as we implement formulas that are increasingly complex, right? And as we do so, we're going to get ahead of time compilation or just-in-time compilation based on the work of the underlying Erlang system and the integration work that Jose's team and Sean have put into place. So this is pretty cool, right? And so we're going to have two backends out of the box, and the community is going to provide some more. So that's the overall lay of the land. So we're going to spend most of our time in Nx proper. So if I drill down into the Nx project, then you could see that I have the def-in itself, and then the back-end pieces, the back-end interface to allow the numerical definition and then the back-ends. And then a bunch of different functions are provided that give me capabilities like the types we talked about, the tensors. Tensors, of course, are going to have a shape. And then there's linear algebra extensions, and then some IEX helpers for things like heat maps. And then there's my def-in extensions and so on and so forth. So this is where we're going to spend a lot of our time in this particular session, especially in this individual tensor piece, which gives us the capability to define and work with multi-dimensional data. And next we're going to create a notebook and start to work with these individual pieces. So we're going to do that next. All right, so let's go ahead and create a notebook, and we'll do a lot of our work in that area. We're going to go to localhost. I already have Livebook running, and so I went to the Livebook code, which is a project that's related to Axon, but it's kind of getting to be a bigger deal, so it's split out into its own project. And I'm going to create a new Livebook. So I'm going to do that here. And this is going to be called Tensor Exploration. And I'm going to create an initial session that we're going to create and shape tensors. Okay, so what we're going to do is create some initial tensors and apply an individual shape to them. So we're going to go ahead and do that next, but I want to talk a little bit about the Livebook capabilities. And so what we have here is essentially what's called a Livebook, which is a live notebook, which allows us to have prose, which is in markdown and section headers. It also allows Elixir, and that will allow me to drop in code, and the code will have side effects such as bindings that can be accessed between the cells, and will allow me to declare modules that can be available between the cells. And then I also have input control, so if I wanted to add a user interface to this notebook, I could. I'm not going to do that in this particular session, but I could do so if I wanted to. So for example, if I wanted to say, these are the instructions for setting up a Livebook for tensors with Nx, right? So I can use GitHub flavored markdown. So backticks can give me, for example, something like this fixed character font, and then I can edit the cell to kind of play with these individual pieces. I can have, like, for example, lists first, second, So I can do all of these things, but I'm not going to spend too much time dealing with live books. That's going to be for another session. Right now, what I want to do is spend most of my time establishing a tensor. So what we want to do is set up an Elixir project. And in my Elixir project, I already have in mix.exs, I believe I already have Nx. If I don't, it'll yell at me. So what I'm going to do is I'm going to say import Nx. And so I'm going to let that fly. And so this is telling me that the module Nx isn't found. So what I need to do is do a mix import. So I'm going to go ahead and grab the lines for that off camera here and then drop them back in here. So one of the things that we need to be able to do is drop in dependencies for our projects. And so I'm going to go get the dependency and I'm going to install that with a mix.install, and that will allow me to have access to this project here. And so when I do so, I'm going to drop in the mix install right here, and we're going to do that next. So I've gone to the Livebook project and I've searched for how to drop in mix install support for the Nx project, which is in development mode right now. So we're going to have to use a git dependency. That's okay, we can do so. And I'm going to drop that in just like this. So I'm going to say mix, drop in here. I'm going to say mix install, and this is the dependency. It's the Nx dependency. This is the version that we want, and this is the option list. So basically we're looking for a git dependency. This is Elixir Nx /Nx, and we're looking for the main branch, and this is the and then we want the sparse option of Nx. So I'm going to go ahead and let that fly. But before I do so, I'm going to do a little bit more setup here. Also, I'm going to say import iex.helpers. So this will allow me to access the same helpers that I use within IEX to support my project. So I'm going to go ahead and let this fly. So this is going to run. It's going to go grab this dependency, and it looks like it's already done so. And then I ought to be able to import this module, and yeah, I can do so. So then I can go ahead and start playing with the tensors, right? And so the first thing that I need to be able to do to work with multidimensional data is to create what's called a tensor, which is Elixir data that has an individual shape with optional names, and then there's potentially a back end that I'm going to access that tensor through. But the main API that I'm going to use to create a tensor is nx.tensor. So let's do that. So let's say create a tensor with nx.tensor. And I'm going to use, there's a /1, /2 version. The /2 will allow me to use some options. We're going to start with this one. And so let's go ahead and let this one fly. And so I'm going to add an Elixir cell, and I'm going to say nx.tensor. And I'm just going to start with a number with 42. And let's see what happens here. Can I create a tensor with just pure numeric data? And it looks like I can. Now this is an odd tensor because it's really not multidimensional. And you can see if I actually take this and I say nx dot, is this a shape? Yeah. If I pipe that nx dot shape and I evaluate this, oh yeah, I need the pipe here. So if I evaluate this says the shape is empty. It doesn't have any dimensions. So this really isn't interesting to me. What I want to do is I want to create some data that looks more like this. And so let's drop that off for now. Let's let that fly. So now I have a tensor. Its shape is 3. That's the first dimension is 3. And you can see that the data has 1, 2, 3. So this is an nx.tensor, and now we can start to play with IEX helpers and see what's going on here, right? So I'm going to say I for nx.tensor tensor, and that can give me the information about it. You can see that this is a tensor. So the data type is a tensor. So this is where some of the functions that I'm going to use on a tensor are going to be found. Turns out that I can also find them in IEX as well. And you can see that this is a struct. So we ought to have a struct key. I ought to be able to take this thing and see what keys are in it, right? So I could say map. So struct is a map. So I could do map.keys. So let's let that fly. So yeah, I can see that this is a struct with data, names, a shape, and a type. Okay, and I can see most of that data when I actually let this fly, right? So I don't see the names, but you can see that there is the type, there is a shape, and there is the data, right? So all the other stuff is there to represent the tensor. And so really what a tensor is, this is effectively a thin wrapper around another API that is wrapped around the implementation of a tensor. And so we can have multi-dimensional data, and that can look like this. Well, actually first, let's take a look and see what the shape of this thing looks like. So I'm going to say nx.shape, right? And I'm going to let that fly. And you can see that this is the shape of it. There's one dimension of size 3. So let's get a bit more interesting. Let's say 1, 2, 3, and 4, 5, 6, and see what that gives me. So this is going to also give me a tensor. Let's hold this in our back pocket for now. So there's my tensor, and you can see, yeah, there's the shape. The last dimension is still 3, and now I have an additional dimension. There are 2 rows, right? So now I can specify a tensor with individual rows, right? So one of the things that I can do, well, and let's actually take a look at what the shape of this thing is, and this ought to give us a 2, 3, and it does because there's 2 rows, 3 columns, right? Okay, so now let's go ahead and see if we can't dive into this a little bit further. Remember some of those data types? Well, let's see if we can't pick up another data type for this nx.tensor. So one of the things that I can do, remember I have access to my IEX helper, so I could say get help for nx.tensor, right? And I'm going to let that fly. So it builds a tensor, arguments. It says there's a Nx default backend, so there is a default backend. Unless I give it a backend option, then I can force one. And then there's also a vector or a list of elements, right? A list of lists or a list, right? And so here's the creation of a tensor with a data type. That's what we did with the 42. Here's a creation of another tensor with a data type. That's great. And now we ought to be able to create a tensor with other data types like this, right? And so it looks like the type is in the shape of a tuple. So let's go ahead and provide a type for our tensor, right? So I could say type. Let's try those Google brain floats. See what that looks like. So it looks like I can't do that. What's going on here? So I can't infer the numerical type. Oh, I see what's happening. I dropped that last. Yeah, there we go. Okay. So now let's try a BR16. And then I don't need that one anymore. So this is not a supported type, but if I give it a supported type of a signed 16, I can do that, or an unsigned 8 to save on the size. I can do that. And I could also give it a type of like a floating point with a 32. Let's see if I can do that. And yep, it's giving me floating points. So I can specify tensors like that. And so what you should notice here is that tensors are basically multi-dimensional data. They have a backend, and what we're allowed to see on the Elixir side through the struct is just the shape, the names, which I can name the dimensions if I want to, and there's a type, and there's data associated with each one. And that's all. The rest is left up to the back end. And so as we go on, we're going to look at a couple of different types of operators, and some of those are going to be unary operators, and some of those are going to be binary operators. And as we get into operators, it's going to take us into the realm of something called a broadcast. So those topics are in the videos to follow. It's going to be a lot of fun. Won't you join me? For Bruce and the dog on the floor, this is Groxio Learning.